Alright, this is Computer Science 305. This is ML2, and we're talking about local variable definitions this time. And so we'll start up SML. And so local variable definitions, inside of functions, we can define new local variables using the let keyword, right, or a let expression, as it's called. So when you use val, the top level to define a variable is visible from that point forward, right? So it becomes essentially a global variable. Oftentimes, though, we want to just create variables within functions, and to restrict the scope of the definition, we can use the let expression, right? And so let expression's grammar definition is shown here. We start with keyword let, and then we insert definitions, and then we say in, and that creates the scope, the expression scope in which these values will be used, and then we end the let, right? So we can create an example. It does not have to be necessarily in a function. It can be anywhere, but it just gives us a way to scope what we're doing. So it's sort of like creating a block statement inside of Java or even Ruby. And so what this allows us to do is say let val x equal 1, and then we say val y equals 2. So these are our two definitions, right? And then we say in, and then give it the expression x plus y, and we say end, right? And so what this will do is give us a small error if we want to call x, right, outside the scope. If we're going to try to use one of these values outside the scope, it will fail, right? Because they were not defined as global variables as we had been defining earlier. So the value of let expression is the value of the expression in the in part, right? So so if we execute let, right, so the value was 1 plus 2, right, the expression form as we see over here, and what it's going to tell us is that the let return value, or the value thereof, is the value of whatever expression was defined inside of it. So variables defined with val between the let and the in are visible only from the point of declaration up to the end keyword. So you can actually do proper indentation for let. So for example, if you're writing code in a text editor, you can actually have this, right? We typically indent it by 2 spaces, right? So it should be essentially let, and then we'll say val x equals 1. We want to normally define each definition on a separate line, just for readability's sake. And then in is at the same indentation level as let, and then 2 in for the expression, and then end starts at the same level as let and in. And so then we end that, and if we and this is sort of what it looks like, right? Some LML programmers put a semicolon after each val declaration and let. It's not required, but you can do it if you wish. You can also create really long expressions with let, right? Actual, like, we would say more interesting expressions or functions than we did before, right? So for example, we want to create a function. If we want to create convert days into milliseconds, right? So we have days to ms, and we want we take in the number of days as our variable. We then can say let val hours equals days times 24.0. The number of minutes equals hours times 60. And the value of seconds equals minutes times 60, right? And we say we're going to use these values in the expression seconds times 1000. And that's good enough, right? Because the semicolon ends the function. So if we were to call this, for example, if we have 3 days, so we say days to milliseconds 3 semicolon. We'll fail because we need an actual real non-integer. So let's try it again. and it gives us a very large number, as expected. So but breaking the expression down makes the code more readable using the let function and the nice indentation. We can also use let with patterns, right? So for example, if we have a list that we want to break in half, right, we can create a function which takes in the base nil, right? So we're going to use patterns to this. It returns a tuple. In this case, if it's nil, right, it returns nil nil. If we have a list that is simply one item, then we'll return a two tuple equal to having the first item will be the original list, and the second item will just be nil. And finally, if we have anything else, right, what we're going to do is we're going to look at the pattern. Now this time we have the first two items, right, A, B, and then we have the remainder of the list. And so what we're going to do is for each item, right, so we have A, cons B, cons CS, right, or C's if you will. And now what we're going to do is we're going to say let, and we'll create a val, which is the initial two tuple, right, val xy equals have CS. So this is telling us that what we're essentially going to do is this is where the breakdown is going to occur. The recursive call is happening in let, and what we're going to say is that we're going to use this val, this xy, right, in the expression where we already have the first two items. And so essentially we're going to take every other item from the list, and we're going to take the odd items and put those in the first part, and we're going to take the even items and put them in the second list of the tuple, and that will give us the halving of the list. And so that's why we need to get the first two items, right? So we're going to, as the head of this list, we'll put a cons with x, which is the value from the tail after being halved, and then we'll take in b and cons that with y, which was the second item of the tuple, and so we actually will be able to use this. So if we look at this, right, we want to execute this on, for example, fun, and we'll sorry, if we call have on the list 1 2 3, it will give us the list 1 3 and 2. If we have 1, as we saw before, it should only give us the pair of the list 1 and nil. And then if we have nil, oh sorry, if we, yeah, that returns the two empty lists. We could also say have, and it gives us the same problem, right? It gives us type var is not generalized because of value restriction are instantiated to dummy types. Let's not worry about that particularly. But as we see, this works. The example takes a list and returns pairs of lists which have in each. We could also see that we could do this without good patterns, right? We could have said val have CS, or val x equals number 1 in halved, and val y equals number 2 in halved. Well, that's without using the value pattern that we saw up here. It's not a very elegant looking experience, right? When we do it this way. In general, as it says here, in general, if we find ourselves using the hash to extract an element from a tuple, we're probably doing something wrong, which is probably true. I also like to say that if I ever, in more imperative languages, if you ever are returning the actual literal value true or false, you are probably doing something wrong. Pattern matching usually gives a better solution, and so I would suggest you really learn how to do this and utilize it as best you can. So there's a nice longer version, right? A longer thing that we've done, and we actually looked at a couple of these. We can go ahead and run a few others, right? So we'll run have 1 2 3 4 5 6 just to validate that it does get the same answer as it shows here, and it does. Looks good. So it's so using these patterns in both the definition of functions, as we as we see down here, as well as for variables, just makes your code look so much cleaner, as well as more readable and easier to understand what's going on. Alright, so this is the end of this example. We will then work a sorting example in the next video, and then you should be good to go.